So now I'm going to talk about two new exponent properties. These are properties we use if our exponent is a fraction. So if I have a base and it's raised to the 1 over nth power, I can rewrite that as a radical. The base is the radicand, so the a is the radicand, and then the denominator in your fraction is the index. So a raised to the 1 over n is the same thing as the nth root of a. I said there were two properties. The second one, if it's not just 1 over n, but let's say it is m over n. So I have two numbers up there. Well, this is equal to, so again, the a stays the same. The denominator, still the index, but that numerator in your exponent is the power. Now, this power, this extra power, the m, you can either do it underneath the radical with the a, or you can do it after. They have equal weight. So I could write that as the nth root of a to the m, or I could write that as the nth root of a, and then all of that is raised to the mth power. Sometimes, well, I actually always find that second way that I wrote it, that last way, is the easiest way to evaluate these. It just kind of keeps your numbers a little bit smaller. Okay, so let's go ahead. I have a raised to the 1 over n. We're just going to practice rewriting these in their different forms, and then we're going to do some simplifying. So a raised to the 1 over n. Let's write that in radical form. Okay, so this would be radical form when you have the radical symbol. And then the other one, we would say rational exponent form. Okay, so here we have rational exponent form. Let's write that in radical form. Okay, so you draw your radical symbol. The base is a, and the denominator is your index. Okay, so what does that look like for this? I have 144 raised to the 1/2 power. Well, what is that? So we're going to draw a radical. So fractional exponent says, okay, that's a radical. So I draw my radical symbol, make the base the radicand, denominator is the index. So what I really have is the square root of 144. Okay, well, that's 12. Okay, what about the next one? Go ahead and convert it to radical notation. Okay, so we draw a radical. There's our 16. 4 is our index. So I need the 4th root of 16. 2. Okay, so now let's practice the other property. So I have the nth root of a to the m. So this is the radical notation. Let's write it in rational exponent notation. So a to the m over n. Index is the denominator, power is the numerator. Okay, right, and the idea is that different times, different ones of these different forms are going to be more beneficial. And so just being able to go back and forth between the two forms is what we're looking for, to have that ability. Okay, so let's do this one. I have 9 raised to the 3/2 power. So fraction in the exponent means it's a radical, so I draw my radical symbol. There's the 9. Denominator is our index. Numerator is our power. So I'm going to do the square root of 9 is 3, and then I'm going to cube that. So 3 cubed is 27. Now I said up here that you could do it in either order, so we could have cubed 9 and then taken the square root of that, but I didn't know those numbers. And if I go smaller first, then I can sometimes figure it out without grabbing a calculator. Okay, let's do that last one. I have 1,000 raised to the 2/3 power. Right, go ahead and convert it to its radical notation. 1,000, remember the denominator is your index, so it's a cubed root of 1,000. And then we're going to square that. So the cubed root of 1,000 is 10. And then when we square 10, we get 100. Okay, so let's do a very quick review here of our exponent properties. So product rule, a to the m times a to the n is a to the m plus n. In words, if we multiply like bases, we add the exponents. Okay. So 10 cubed times 10 to the 6th. The base is 10. Both are 10. So if I'm multiplying those together, my answer is 10. Base stays the same, and then I add those exponents. So 10 to the 9th. Quotient rule, a to the m divided by a to the n. Divide, we subtract, right? So divide like bases. So like means they're both the same letter, same number, something like that. We subtract, top minus bottom. So subtract the exponents. Top minus bottom. Okay, so if I have 9 to the 8th divided by 9 to the 5th, that would be 9 to the 8 minus 5, or 9 cubed. Okay. Power rule. If I have, right, a raised to the m power, and then that's raised to the nth power, powers to powers, we multiply. So that's a to the m times n. So what I'll say is powers raised to other powers, multiply. So if I have 10 cubed and then that's squared, so 10 cubed squared is 10 to the 6th, 3 times 2. Product to a power, so if I'm multiplying inside and that's raised to a power, then I can distribute that power to the different factors. So a times b raised to the mth power is a to the m times b to the m. So when a product is raised to a power, raise each factor to the power. Okay. And I have this example here. I'm going to cross this one out. I'm going to do a different one. So let's say I have 2 times 3 squared. Okay. So the product to a power property says, okay, that is 2 squared times 3 squared. Okay. So I just want you to see that that's actually, right, that these two are equivalent. So if I do the top one, 2 times 3 is 6. 6 squared is 36. Okay. But down here, if I bring the 2 in, because everybody was multiplying, I get 2 squared is 4 times 3 squared is 9. 4 times 9, also 36. Okay, a quotient to a power. A to the m divided by b to the m. I'm sure you've written it down, right? The power just pops in. So when a fraction is raised to a power, numerator and denominator get the power. Okay. So 2/3 raised to the 4th power. We can get that by doing 2 to the 4th divided by 3 to the 4th. So 16 over 81. Okay, 0 power. If you have anything, caveat, a is not equal to 0. Anything but 0 raised to the 0 power, that is 1. So anything except for 0 raised to 0 power equals 1. So 8 to the 0, it's 1. And exponent of 1, a to the 1, is just a. Typically, if the exponent is 1, we don't write it. Sometimes you'll see it just for emphasis, but usually we don't. So anything raised to the 1st power equals itself. So 16 to the 1st power, 16. And then finally, negative exponents. a to the negative m. So this is a little bit tricky, so just kind of, right, keep your wits about you. If the exponent is negative, what it does is makes a reciprocal of the base. So that's 1 over a to the positive m. So the negative sign does the reciprocal of the base. So instead of a, it's 1 over a, and then the exponent becomes positive. Okay. Negative exponents create reciprocals of the base. Okay, so if I have 10 to the negative third power, that's 1 over 10, right? So reciprocal of the base, and now the power is positive. Okay, so 1 over 10 cubed. So let's just practice simplifying, right? And so we're going to bring in those rational exponents, right? So we practiced simplifying them when we just had a number, but let me show you how we can kind of use our exponent properties and those rational exponents to do some a little bit easier simplifying. So x cubed raised to the 2/3 power. So I have powers to powers. So what are we supposed to do for powers to powers? Right, we multiply. So now I have x to the 3 times 2/3. And 3 times 2/3, right, if you want to stick a 1 under your 3, my exponents are getting kind of big, right? Keep in mind they're supposed to be smaller and up a little bit. So the 3's can cancel. So this is equal to x squared. Cool. Let's do the next one. So I've got a product to a power. I've got a negative exponent. I've got a fraction. I got a lot of stuff going on. So you just want to take little steps, right, and kind of pick away at all of the things that need fixing. So I'm going to do the product to a power first. So the 4 is going to pop in. So I have a to the 3/4 to the 4th power times b to the negative 1 to the 4th power. Okay. So now I'm going to do powers to powers. So I'm going to multiply. So 3/4 times 4 is 4, or 3, sorry, 3/4 times 4 is 3. So that first factor is going to be a cubed. Right? If you want to write out your multiplying your fractions again, go right ahead. And then I have b to the negative 1 to the 4. Powers to powers we multiply. So that's going to be times b to the negative 4. Now, typically we don't leave negative exponents in our answer, so let's go ahead and rewrite that with only positive exponents. So the a, it does have a positive exponent. It's going to stay where it was, so a cubed. But the b to the negative 4 is going to go down below, right? It's going to do the reciprocal of that. So it'll be a cubed divided by b to the positive 4. Remember, once it goes below, it gives up that negative sign. Okay, I've got b to the 3/5 times b to the 7/5. I'm multiplying like bases. Multiply like bases, so we add the exponents. So I have 3/5 plus 7/5, like denominator, so go ahead and add those together. 3 plus 7 is 10, so b to the 10/5, and 10/5 reduces to 2. So that's b squared. Cool. Do you want to pause and give it a shot on your own for the next 3? Okay, let's see. For this one, I have negative 8b cubed raised to the 1/3 power. So I've got a product raised to a power, so I'm going to go ahead and use my product property. So I have negative 8 to the 1/3 times b cubed to the 1/3. So the b cubed to the 1/3, that's nice. That's just b. The negative 8 to the 1/3, I might write that in its radical notation instead, just because I feel better when it's just numbers, right? Because I know those. So I have negative 8 is my radicand. 3 is my index. So I have the cubed root of negative 8. That's negative 2. So there's my final answer, negative 2b. Okay, next, 16 over 49 raised to the negative 1/2 power. So I didn't write this in my negative exponent step right here, but you can. If you have a fraction itself raised to a negative exponent, right, it's the reciprocal of the base. Well, this time it's that whole fraction that's the base, so I need the reciprocal of the whole fraction. Reciprocal, right, fancy word for flip. So flip your fraction, and now that power is positive. So 16/49 to the negative 1/2 is the same thing as 49/16 to the positive 1/2. And now I'm going to go ahead and put that into radical notation because they're all numbers and I just feel better that way. So I'm really doing the square root of 49/16. Square root of 49 is 7, and the square root of 16 is 4. Kind of fun, right? Okay, finally, we can use our second exponent property, our second new exponent property, to simplify radical expressions when we have some big numbers. So let's rewrite the fifth root of x to the 30th with a rational exponent. So here's a case where switching to rational exponents is going to be easier. So what is that? X to the what? Right? So you make your little fraction. Index is the denominator. Power is the numerator. So fifth root of x to the 30th is equivalent to x to the 30 over 5. Well, 30 over 5 is 6.